Alright guys, so today we are looking at the question, does a battery really maintain a constant pressure difference? And we just did activity 5 of unit 5, and essentially what we found out was no, the battery does not really maintain a constant pressure difference. While that is the job of the battery itself is not perfect and it does have its limitations. And so eventually we did see that the battery's pressure difference does decrease as it gets older, and as we decrease the overall resistance of the circuit. So let's go ahead and take a look at what happened in this activity, and then we'll also go ahead and look at the consequences of that. So what we did was we added bulbs in parallel on the right side of the circuit. And what we did essentially was we decreased the overall resistance of the circuit by adding these bulbs in parallel. We started with a long bulb and then moved on to the round bulb here, which had less resistance, and then two round bulbs in parallel had even less resistance than that first round bulb. Now, because they are all in parallel, something that is important to notice is that all of these bulbs here and the battery have the same pressure difference across them. And that is because this is just wires in here, and the wires have very, very low resistance. All of this wire here, when we connect it, all of that wire will be red. All of this wire will be blue, because those wires have very, very little resistance. And so what we're going to do is we're going to look at what happens when we do that. And what we see is that, again, adding branches in parallel decreases the overall resistance of the circuit, which increases the flow rate through the battery, which in this case is our trunk. So if we look at this, if you noticed the way that I had connected the circuit while I was doing the activity, while we do see this kind of as branching out like here, like maybe we see this as the trunk wire, that's not really the trunk wire. If you noticed how I had it set up, I basically had one wire here, and then all of these other branches sort of flowed out of that trunk wire, which was connected to the battery. So if the battery is our trunk, we were increasing the flow rate through the trunk wire through the battery, which shouldn't affect the flow rate in the other branches because the pressure difference across the battery should be staying the same, but we're actually seeing that it does affect the flow rate in the other branches. Essentially, what we would be doing if we take one round bulb and then we add another round bulb in parallel to it. Okay, so I'm going to just draw a quick circuit here. If we had a round bulb like this, right, that has some resistance R. And what we did with activity 4 was we looked at sort of mathematically, but not quite yet. But we definitely decided that if we add another identical bulb in parallel, we should be cutting the resistance in half. Which means that the flow rate here should double. But since we're seeing that the brightness of those bulbs does decrease a little bit, right? We saw that the brightness of those bulbs does decrease slightly. That means that the flow rate through the battery here is not doubling. It's actually slightly less. That means that when we add this bulb in parallel, even though we should be cutting the resistance in half, we're actually not quite cutting it in half. Because while it does decrease the resistance of these two bulbs together, it doesn't actually have an effect on the resistance of the battery. So as we add more bulbs in parallel, we see the effect of the resistance of the battery more and more. Okay, so here's a basic consensus from what I just talked about. We have decided that batteries do have a small internal resistance. And usually when we're looking at our circuit, the internal resistance of the battery is much, much smaller than the overall resistance of the circuit. Okay, that little r, the internal resistance of the battery, is very much smaller than the overall resistance, the big R, for the whole circuit. And when that's the case, we don't really notice the effect on the pressure difference across the battery. But as the resistance of the battery and the resistance of the whole circuit start to get closer together, we begin to notice the effects, and the pressure difference across the battery gets less and less. If we get to a point where the internal resistance of the battery is greater than the overall resistance of the circuit, then the electric pressure difference across the battery will eventually approach zero and disappear. Once that electric pressure difference across the battery is zero, our battery is dead. It no longer works. There is no longer flow through the battery, and so the battery is dead. Tomorrow you're going to be looking a little bit deeper into that, what it is that actually kills a battery, why that happens, the internal structure of a battery, which we've talked about briefly in the past, and then you'll do a simple worksheet on that. And then that will finish out your week. So yeah, have a good rest of your day, guys. Bye.